Here we go, guys. Going to go over the homework. 1.4 WSP. On the first part, you're going to evaluate, which simply means to plug it in. So we're going to take those values and plug it in. We're going to take the value of D, which is negative 1.4, plug it right in here, and the value of A, which is negative 1, and plug it right in there. Let's first zoom in. So D is negative 1.4, so we're going to put it in parentheses because it is multiplication right there, negative 1.4. And the A value is negative 1, so you don't really need the parenthesis right there, so I'm just going to put a negative 1 like that. And inside the absolute values, remember absolute values, we kind of treat them like parentheses. So you look at the inside and you do the math inside. We have multiplication and addition, and according to PEMDAS, you're going to do multiplication first. 10 times negative 1.4 is negative 14. Okay. Whenever you multiply by 10, it simply moves the decimal one space over to the right. So that becomes negative 14. And we still have the plus negative 1, and that is still inside the absolute values, and there's still a minus sign on the outside that comes down in front. Now, what is negative 14 plus negative 1? That's negative 15, and that is still inside the absolute values, and there's still a negative sign out in front. Please do not make the mistake of changing these guys to positive. That would be incorrect. Remember, absolute values kind of like parentheses. You do what you can in there, and you can actually do the absolute value of negative 15. The absolute value of negative 15 is positive 15. And the negative sign that's out here in the front, that's just going to come down, and that will be part of your answer. So your answer is negative 15. That's number 3. Let's jump to number 7. So we're going to zoom in a bit, and we're going to substitute the values. A is negative 1, C is 5. So let's do that. Let's rewrite it exactly the way it is. And as you can see, I left some blank spots here because I'm going to plug in the A value of negative 1, and I'm going to put it in parentheses because I am multiplying 5 times negative 1 right there. And the C value is 5, and I'm also going to put that in parentheses. Let me do a different color here. I want to put the C value of 5 right in there, and of course we are multiplying because there's no sign. So this is our math problem. Now let's actually simplify it. So on the inside of the absolute values, we need to simplify. On the first absolute values, we have multiplication and subtraction, and according to PEMDAS, you need to multiply first before subtracting. So 5 times negative 1, that is negative 5. Bring down the minus 7, rewrite everything, okay? Now we have negative 5 times negative 7, well, that will be negative 12. You owe 5, you owe 7, you're going to owe a total of $12. And again, that's still inside the absolute value. And finally, last but not least, the absolute value of negative 12, that is positive 12. That's your final answer right there. However, that's only half of the problem. We still need to add, so let's bring down that plus sign. We need to add whatever we get over here as an answer. So let's begin again with multiplication right here. 5 times 3. 5 times 3 is, or 3 times 5 is 15. And then bring down the minus 4, 15 minus 4, and it's still inside absolute values. 15 minus 4 is 11. So we really have an 11 in here. 15 minus 4 is 11. And the absolute value of 11 is 11. So we could just bring down that 11 right there, and you have the numbers 12 plus 11. Final answer is 23. Boom. Let's go to the next question here. Let's actually jump to, let's do number 8, why not? So let's find out what the C values are and the A value. A value is negative 1, C value is 5. Okay. A value is negative 1, C value is 5. Let's again rewrite everything and then plug in those values. So the C value is 5 and the A value is negative 1. Okay, let's do the math. In the first absolute value, 7 times negative 5. And let me actually squiggly underline that. 7 times 5, that's what we have it. 7 times 5, that's 35. Okay, now the 1 that's in front and the minus sign comes straight down, right? That 1 comes down, the minus sign comes down. And it's still inside absolute values, okay? And we still have the minus sign out here and the absolute value of negative 1. So do not make the mistake of changing these, right? Don't change the minus minus to plus plus. You could do that when you have parentheses, but not absolute values. So let's do the absolute value. The absolute value of -1, that's +1. Okay, so we are going to bring down this minus sign right in front of that 1. And over here, on the inside of this absolute value, we now have -34 because 1 take away 35 is -34. And of course, we still have the absolute values around it. Final step here, the absolute value of -34, that's +34. Bring down the -1. 34 minus 1 is 33, and that's your answer for number 8. Let's jump to the next part of the homework, which is solving each equation and their absolute value equations. And they also tell you to check your solutions. So we should know, after taking notes and paying attention in class, we should know that whenever the first step is to isolate the absolute value, and it's already isolated. There's no ×5 out here. There's no +7 back here. The absolute value is all by itself on the left side of the equal sign. So we're ready to rock. We're ready to set up the two situations, the positive situation and the negative situation. Okay. Now remember, the positive situation is writing it exactly the way it is without the absolute values. Okay, we're going to just forget about those absolute values and write it without it. So x minus 13 equals 2. And for the negative situation, it's the same exact thing without the absolute values, but we're going to change the sign of whatever this right-hand side is. So it's a +2. We're going to make it a -2. Okay, but everything else is going to stay the same. The equal sign, the x minus 13. So I hope we understand that big difference. Positive situation, writing it exactly the way it is. Negative situation, writing it exactly the way it is, but changing the sign on the right side. So let's solve both of these now. We have a +13 to get rid of the -13, +13. We're going to end up with x equaling 15. That is one answer. And the other one, +13, and then +13. It's going to be x equals 11. That's another answer. So we actually get two answers, and we're supposed to check our solutions. If I put a 15 right here, 15 take away 13 is 2, and the absolute value of 2 really is 2. That's what we call double checking. All right, now let's go for the other one. Let's double check this guy. 11, plug in 11 right there. 11 take away 13, that's -2, and the absolute value of -2 is also +2. So we have double checked both answers, and they both work. So both of those are our answers. Sometimes only one answer works, the other one's extraneous. Remember, it's just an extra answer that you got that did not work. Sometimes no answers work, which would make it no solution. So let's continue on right here. Let's go to number 16. 16, step 1 is not done for us. We have to isolate the absolute value first. So right here it says 7 times this big giant absolute value. We want to get rid of the 7 times in front of the absolute value. How do you get rid of something? You do the opposite. The opposite of multiplication is division. So we're going to divide by 7. 7 divided by 7 is 1. It cancels out. And what you do to one side, you do to the other side. So we're going to have 42 divided by 7 on the other side. So let me rewrite my absolute value equation. So far, it's the absolute value of x plus 3 equals, what is that? 6. So there's our absolute value equation, and it does have the absolute value isolated. And now let's do the positive and negative situation. The positive situation is writing it exactly the way it is, x plus 3 equals 6 without the absolute values. The negative situation, it's the same exact thing, x plus 3 equals 6, but what do? We change the sign of the right side. So I need to change this 6 to a -6. So that's the positive and the negative situation, all right? Now we're going to solve both. How do we get rid of a plus 3? Well, we're going to get rid of plus 3 by doing a -3. That'll cancel. What you do to one side, you do to the other side. You're going to end up with x equaling +3. That's one answer. Let's try the other one. Subtract 3. Subtract 3. Now in this case, we have x equaling -6. Take away 3. That's actually 0.6. You owe 3. You're going to owe a total of 9. And those are your two answers so far, but you're supposed to check actually, all right? So you could check by plugging it into the original and making sure that this side equals 42, or you could even plug it into the isolated one and make sure that when you plug it in, it gives you 6. So if I plug in 3 right here, 3 plus 3, it really is 6, and the absolute value of 6 is 6, so we're good. If I plug in a negative 9 right here, negative 9 plus 3 is negative 6, and the absolute value of negative 6 really is 6, so it works as well, so those two answers do work. Alrighty, let's move on. Let's do number 17. Why not? Yeah, 17. 17. Let's do, since it's isolated, let's do positive and negative situation. And the positive situation is writing it exactly the way it is without the absolute values. And the negative situation is the same thing as this, but all I have to do is change the right side to change the sign, right? So if it's positive 42, I'm going to make it negative 42, and that's what I'm going to write over here. And now we're going to solve both. On the left equation, we go plus 6. We're going to end up with 3u. The equal sign comes down. 42 plus 6 is 48. And then we're going to finally divide by 3. So our final answer is u equals 16. 16 times 3 is 48. On the other one, plus 6, negative 42 plus 6, that will be negative 36. So what we have is 3u equaling that negative 36. And finally, we are going to divide. To get rid of that multiplication of 3 in front of the u, we're going to divide by 3. And what you do to one side, do to the other side, divide by 3. You will get your final answer, u equaling negative 12. And of course, you should double check both. Plug in 16. Right here, that'll be 48. 48, take away 6, the absolute value of that is 42. And when you plug in negative 12, that's 3 times negative 12, that's negative 36. Minus 6, that's negative 42. And the absolute value of negative 42 really is positive 42. So it does work. Both of them are correct. Both of them are required for you to get full credit. So jumping to number 18. This one already has the absolute values isolated. So what do I do next on number 18? If it's already isolated. Positive and negative situation? Anybody else have any other ideas we could do here? No solution. Perfect.
Oh, sure.
Yeah. So always look out for that, guys. If your absolute value is isolated and it equals a negative number, you could just put the no solution symbol and you're done. Now, it would be a different story if this would have been a negative 6x. Then you'd have to keep going. But because it's just a regular negative number, it's no solution. There's no way that you could do the absolute value of anything that'll give you negative 6 as an answer. It's impossible. That's why it's no solution. Let's go to 19. How about here? What do I do? Isolate, divide by negative 3. Divide by negative 3. And what do we have? We have an absolute value of 4x minus 9 equaling negative 8. And right there, once again, no solution. Maybe I should just give you a bunch of these questions, no solution ones on a quiz on Friday. They're easy. 21. Did we do this on the class opener? We did, right? So on this one, if you're watching this video and you want to see this explanation, watch the opener video that is on there. 22. 22, what do I do? Isolate? Okay, it's already isolated though, right? What next? Positive and negative situations. How do I do the positive situation? Same thing without the absolute values. There it is, 4w minus 1 equals 5w plus 37. How about the negative situation? It's the same thing, but you just change the signs of the entire right side. It's kind of like multiplying that binomial by negative 1. All right, so let's solve both of these. On the left equation, let's get rid of the minus 4, or the 4w by doing minus 4w, minus 4w. We are going to end up with negative 1 equaling 1w plus 37. Final step would be to subtract 37. Subtract 37. Final answer is w equaling negative 38. W equals negative 38. Now for the other one, I'm going to add 5W. Add 5W. We end up with 9W minus 1 equaling negative 37. And then I add 1 and add 1. 9W equals negative 36. Final step will be to divide by 9. Divide by 9. W equaling negative 4. So the question is, do both of them work? I have no idea. If I try negative 38 right here, that's going to be a huge number. Let's do that with the calculator. If you end up doing number 22 correctly, you get those two answers, but when you test it, the negative 38 will be extraneous. So the only answer that you'll see on the back on number 22 is negative 4. But let's jump to, are we doing 24? No, we're skipping 24. Going for 25. Okay, if you want to see 25, did we already do this one on the notes? Yes? Okay, so if you want to see the video explanation of number 25, watch the previous video. How about 26? Did we do 26 on the notes? No? Okay, so let's isolate that guy. What do I do? We did it? No, we didn't do it. Okay, so let's isolate it. What do I do to get the absolute value by itself? Even before that, let's get rid of the subtract 5, right? So that would cancel it out. What I do to one side, I do to the other side, right? Let me rewrite what I have. I have a negative 3. I have the absolute value of 2 plus 2W, close absolute value, equals negative 12. What do I do next? I divide by negative 3. And what I do to one side, I do to the other side. So some of us might be thinking, oh, no solution, but that negative 12 divided by a negative 3 becomes positive. So we do need to continue working. 2 plus 2W equals positive 4. So once it's isolated, you want to do the positive and negative situation. Positive, negative, squiggly line. Positive situations, writing it exactly the way it is without the absolute values. And the negative situation is the same thing, but changing that 4 to a negative 4. Now we're going to solve both of them. The one on the left, you subtract 2, you'll end up with 2W equaling 2. And the final step, to get rid of the multiplication of 2, you divide by 2, you'll get W equals 1. That's one answer. I mean, it might be an answer. We need to double check it. The other one, we're going to subtract 2. We will get 2W equals negative 6. And when we divide by 2 and divide by 2, we'll get W equals negative 3. That's another answer. So to double check, I am going to plug in those answers into the isolated absolute value equation. So when I go 1 plugged right in here, that'll give me a 2, and 2 plus 2 is 4. And of course, the absolute value of 4 is 4. So this one works for sure. If I plug in negative 3 right in here, 2 times negative 3 is negative 6. Negative 6 plus 2 is negative 4, and the absolute value of negative 4 is also 4. So both of these work. You have to put both of them to get full credit. If you check the answers on the back, it'll be right there, both 1 and negative 3. And 28. Did we do 28 on the opener? No? Okay, so let's isolate. What do I get rid of first? The 3. Okay, so let's get rid of that 3. It's going to end up being negative 5. Absolute value of 2D minus 3 equals 1. Next step. Divide by negative 5. Maybe. Oh no, it would be. The absolute value of 2D minus 3 equals the ugly fraction negative 1/5. However, we know that an absolute value can never be equal to a negative number. Okay, so you could just stop right there. Do not do the positive and negative situation. Just stop right there and put no solution, and we're done.